So the LIGO Scientific Collaboration is a group of scientists, about 1,200, who are involved in detecting gravitational waves. The gravitational waves were a prediction of Einstein's theory of general relativity. They are emitted by objects that have a lot of mass and that are accelerating. If you take any object that's very massive and is moving very fast, it should radiate gravitational waves. The science of gravitational waves includes building instruments that are sensitive enough to detect them, working on the theories that we need to understand the sources of gravitational waves, and on algorithms for extracting very faint signals from noisy instruments.
Our detectors are 2.6 miles apart. At the end point of those things, we're measuring motions that are 1,000th the size of a diameter of a nucleus of an atom. The discovery that was made on the 17th of August in 2017 was a very different signal than we had seen before. Well, that was quite dramatic.
We have, for the first time, seen both gravitational waves and light from the collision of two dense dead stars called neutron stars.
Today's announcement should excite the scientists and non-scientists. It's a measure of what is possible when we have the courage to push beyond the limits of our knowledge and pursue answers to big questions.
So what we saw were a pair of neutron stars. These are stars that weigh about what the sun does, the size of only an average city like Washington, D.C. or Boston.
When neutron stars orbit each other, they give off gravitational waves, which we could see. And as those gravitational waves carry away energy, these neutron stars get closer and closer to each other. They speed up in their orbits, and eventually they collide.
What they did is they made a chirp that sort of rumbled. It goes whoop, like that. And that's what we heard 1.7 seconds after LIGO heard that chirp. The chirp was over, and bingo, 1.7 seconds after that, we saw a pulse. A gamma-ray telescope saw it, and then another detector in Italy also had evidence that there was this event, and with the evidence from the Italian detector and from the LIGO detectors, we could put a circle on the sky, a very small region of the sky. We could tell people, go look in that region, and you will find something really spectacular. And so it turns out, very shortly after that, within about 5 or 6 hours, people on the ground with ground-based telescopes saw that same thing. And that was very exciting to everybody.
It was, in my opinion, one of the most landmark scientific discoveries of our time, because we saw this collision initially through gravitational waves, and then we saw the light show that followed. It really is the first time that we as humans have been able to combine sight and sound in the same cosmological observation. For most of our human history, we've been watching silent movies. And now for the first time, we're also getting gravitational waves from the same objects along with the light, and that allows us to turn our silent movies into movies with sound.
A lot of people are very skeptical that we could ever make this thing work. There was all sorts of questions about whether gravitational waves actually existed in the early days. Then, even if they did exist, could you ever make an instrument that was sensitive enough to make the measurement of them? The fact that gravitational waves were discovered in our epoch, as measured, was a very important scientific milestone. It's a brand new way of looking at the universe.
These long-term investments sometimes have to be made, and when they pay off, they can pay off big. Getting to this place of being able to detect gravitational waves certainly hasn't been easy. And that's been both challenging, but also one of the great pleasures of being part of this endeavor.